Good morning, everyone. Today we're going to do some problem sums involving the use of algebra. Let's start with the very first example. Okay, the first example reads, the sum of 4 consecutive odd numbers is 56. Find the greatest of the 4 numbers. Now in algebra, we will always let one of the answers be x. So for part A, I let the smallest odd number be x. That would mean that the next 3 consecutive odd numbers will be x plus 2, x plus 4, and x plus 6. Now next, I have to read the piece of information. They say that the sum of 4 of the consecutive odd numbers is 56. So I try to form an equation using this piece of information. So I add up the 4 consecutive odd numbers. 1, 2, 3, 4. All added together to be equals to a sum of 56. So I form an equation. Now I just solve the equation to find the answer to one of the answers to my problem. So I simplify the left hand side of the equation. So x plus x plus x plus x will give me 4x. Plus 2 plus 4 will give me plus 6. Plus 6 plus 6 will give me plus 12 is equals to 56. So now I seek to solve for x. What can I do to the plus 12? I minus 12 on both sides. So I have plus 12 minus 12. That will give me 0, leaving me with 4x on the left hand side. 56 minus 12, that will give me 44. And now what do I do to both sides? To get x, I divide by 4 on both sides. So I'll get x, and here if I divide by 4, I'll get 11. Now I can answer the question already. What is the greatest of the 4 numbers? So I answer with a final statement. Therefore, the greatest of the 4 numbers is 11 plus 6, so which is 17. So that's all for part A. Now let's move on to part B. If a number is tripled, it gives the same result as when 28 is added to it. Now as I've mentioned, we'll always let x be the answer. So let the number be x. So the number is being tripled. That would mean that x multiplied by 3. So it's 3x equals to the same result as when 28 is added to it. So if 28 is added to x, I'll get 28 plus x. So it's the same result as 3x. So here I go, I form an equation. Now to solve this equation, notice that there are 2 x terms on both sides, so that's not allowed. I must get rid of one of them. So I minus x on both sides. So if I minus x, I get rid of this. I'm left with 28. 3x minus x, I'm left with 2x. Now, how do I solve for x? That's right, I divide by 2 on both sides. So if I divide by 2, I can cancel the 2. Divide by 2, I get 14. So the value of x is 14. Now I must answer the question. Therefore, the given number is 14. Let's move on to the next example. In this example, it says that the numerator of a fraction is 5 less than its denominator. If 1 is added to the numerator and denominator, the new fraction is 2/3. Find the fraction. So here I have to form an equation. Now let's read the first statement again. The numerator of a fraction is 5 less than its denominator. So in this case, I let the numerator be x. Since the numerator is 5 less than the denominator, this would mean that the denominator is 5 more than the numerator, which means that the denominator will be x plus 5. Now next, I have to form the equation. They say 1 is added to the numerator and denominator. So I add 1 and I add 1. the new fraction is 2/3. So it's equals to 2/3. And there I go. I have formulated an equation. So with this, I can simply cross multiply, expand the brackets, and solve for x. So since x is the numerator, the given fraction will be 9 over the denominator will be 5 more, which is 9 plus 5, that will be 14. So remember to answer the question with a final statement, since this is a problem sum. So that's all for this example. Next is the age problem. They say the sum of the ages of Susan and Tom is 36. 6 years ago, Susan was twice as old as Tom. Find their ages in 5 years' time. So let's let the answer be x. So I let the age of Susan be x years old. And since the sum of the ages of Susan and Tom is 36, therefore the age of Tom is 36 minus x years old. So this is their current age. Now 6 years ago, what is Susan's age? It will be x minus 6. And what was Tom's age then? It will be 36 minus x minus 6. Now they say 6 years ago, Susan was twice as old as Tom. So this is Susan's age is equals to twice Tom's age 6 years ago. So you can see that I formulated the equation. Now I just have to solve this equation, find the value of x, which is the answer to the problem. So let's expand the inner brackets first. When I open up this brackets, I'll get 36 minus 6, which is 30, minus x. And the left hand side remains as it is, x minus 6. Then I expand the brackets on the right. 2 times 30 will give me 60. 2 times x will give me 2x. And so I get this equation. Now since I got 2x terms on both sides, I add 2x on both sides. So I get rid of this term. X plus 2x will give me 3x. And then after that I plus 6 on both sides. That will give me 66. And this minus 6 is gone. And how do I get the x? I divide by 3 on both sides. So I'll get x equals to 22. So they want me to find the ages in 5 years' time. So this is Susan's age currently. So 5 years' time will be 22 plus 5, which is 27. And Tom's age currently is 36 minus 22, which is 14. 14 plus 5, that will give you 19. So I have to answer the problem with a final statement. Therefore, the ages in 5 years' time will be 27 years old and 19 years old, respectively. So that's all for this age problem. Now let's move on to the last problem on algebra. This is a mixture problem. Here the question reads, solution A consisting of 20% of sucrose is mixed with solution B containing 60% of sucrose. So a 1000 cm cube mixture consisting of 50% sucrose is formed. Calculate the volume in cm cube of each type of solutions mixed together. So again, I let one of the answer be x. So I let x cm cube of solution A be used to form the mixture. And so how much volume is of solution B? Therefore 100 minus x cm cube of solution B. Alright, I miss out the term B here. Kindly add on your answer. 100 cm cube of solution B is then used to form the mixture. Now I'm trying to form the equation by equating the amount of sucrose in the mixture. In solution A, there are 20% of sucrose. So I take 20 over 100 times the total volume of solution A. That will give you the volume of sucrose in solution A, plus the volume of sucrose in solution B will be 60% of sucrose. So it's 60 over 100 times the volume of solution B. And that will be equal to 50% of the sucrose in the resultant mixture. So it's 50 over 100 times 1000 cm cube of the final mixture. So in short, I'm adding the volume of sucrose in solution A to the volume of sucrose in solution B, giving you the amount of sucrose in the resultant mixture. So next, I find that there's over 100 in each term. I times 100 on both sides of this equation. So when I times 100, I cancel away this, times 100, I cancel away the denominator, and then when I times 100, I cancel away this denominator. So you get 20 times x, which is 20x, 60 times this bracket, giving you this term, is equals to 50 times 1000, which is 50,000. Now I seek to expand this bracket, so 60 times 1000 give you 60,000 minus 60 times x, that will give you 60x, which is equals to 50,000. So 20x minus 60x will give me minus 40x. And then I minus 60,000 on both sides, minus 60,000, this will be 0, minus 60,000, that will be minus 10,000 on the right hand side. Now how do I get rid of the minus 40? That's right, I divide by minus 40 on each side. So I divide by minus 40 and I divide by minus 40 on each side. So here minus 40 cancel out each other, giving you x, and then right hand side minus 10,000 divided by minus 40 will give you a result of 250. So the conclusion is therefore 250 cm cube of solution A is mixed with 750 cm cube of solution B. So that's all to this mixture problem using the method of algebra. So we have come to the end of the lesson using algebra to solve simple problem sums.